a Portland Community College Mathematics telecourse, a course in arithmetic review, produced at Portland Community College. But now one begins to realize that fractions can be expressed in three different ways. First as a simple fraction, and then the same number as a decimal, and that same number again as a percent. Most of this chapter so far has been involved with going back and forth from one form to the other. For instance, on one of your exercises, you started with the fraction 3/4, divided 3 by 4, and converted it to a decimal. Then you moved the decimal point 2 places to the right or towards the percent and converted that same number to a percent form. Now the important thing for us to realize is that all three of these stand for the same value. If we were to say 3/4 of something or 75% of something, we are saying the same thing, just in a different language, if you would. This lesson will simply have you going back and forth in different orders to try to iron out any confusion you have about which way you're going. Recall that if I'm changing a decimal to a fraction, we simply pretended like the decimal point wasn't there, write the number over 1, then for each decimal place we put on a 0 and then reduce. And if we reduce that fraction by dividing top and bottom by 25, we would get the fraction 3/40. On the other hand, if we wanted to convert this to a percent, we had a rule to move the decimal point 2 places to the right, or if you would, towards the percent, and that would give us 7.5%. And we're done. Now let's start with the percent form and go to the other two. Recall we said that if you want to get away from a percent, you move 2 places away or to the left, whichever is easier for you to remember. Then if you create extra places by doing that, you insert a 0. So 9.5% is 0.095 as a pure decimal. And again, to convert this to a fraction, one of the ways we gave you was to say this as a word name. So that's 95 thousandth. So we simply write it, 95 thousandth, and then reduce. In this case, we can see that both top and bottom is divisible by 5. So dividing top and bottom by 5, we would get 19/200ths. And thus we see that 19/200ths, 0.095, and 9.5% are in fact three ways of saying the same number value. Now let's do another one, starting with a decimal with a fraction and go both ways. Well, if we're converting to a percent, we still move the decimal point 2 places to the right, or if you will, towards the percent, and then stick the percent sign on. And in this case, of course, we don't really need that decimal point. In going from a decimal to a fraction, when the decimal had a fraction with it, we had a special shortcut. Do you recall that? Pretend like the decimal point isn't there. Convert this to an improper fraction, so that would be 13/6. Then for each decimal place, and there are 2 of them, we append 2 zeros, and that's it, unless it's reducible. So again, 3 forms of the same number. The question that will come up in this lesson is, are there any tricks which will help to keep oneself from becoming confused as one goes back and forth? First, one usually has no problem between going from fractions to decimals, or from decimals to fractions. And the key here, of course, is in the fraction bar, which one simply recalls means divided by. So this reads 3 divided by 8, and we do it. And one has the decimal equivalent. On the other hand, if one wishes to go from a decimal back to a fraction, one basically only had to be able to read this. First, the place values, tenths, hundredths, thousandths. So we have 82 1,000th, and we simply write what we just got done saying, and then reduce. For this, we did have a trick which one could use if one wanted to. We suggested that you pretend like the decimal point isn't there and write the number over 1 in this case. Then for each decimal place, append a 0, and you get the same results, again, which is reducible. So going from fractions to decimals, or decimals back to fraction, usually does not bother a person. On the other hand, going back and forth from decimals to percents does bother people sometimes. And that is usually with the direction the decimal point has to be moved. Most people remember that you always move it 2 places. Sometimes they just forget which way. Again, first do remember that it always does move 2 places. Now try to rephrase the situation as follows. Realize that you either want to change either to a percent, or you're trying to get away from a percent in the case of going to a pure decimal. So always ask yourself, do I want to change this representation to a percent, or do I want to change this to a representation which it gets away from the use of a percent? That way, it turns out that if you're changing to a percent, you move the decimal point 2 places to it. If you're trying to get away from the use of a percent, you move it 2 places away. So the statement of the question in this manner tells you which way to move the decimal point. An example, here's a pure decimal. If I wanted to change it to a percent representation, I would move it 2 places to the percent and stick the percent sign on. But here's a percent, and if for some reason you want to get to a pure decimal, then you will drop the percent and move the decimal point 2 places away, because I want to get away from the percent. Again, if you're changing it to a percent, move it 2 places towards a percent. If you're trying to get away from the percent, you move it 2 places away from the percent. Quite a neat trick, and it's easy to remember. Don't let this particular choice in order of writing fool you. It is the question one asks that help you, not how you wrote it. For instance, here I reversed the order, but in this case, if you want to get away from a percent, you move it 2 places away, which will give me 0.004. But if I have a decimal and I want to change it to a percent, I move it 2 places to the percent, which gives me 40% So again, to get away from a percent, move it 2 places away and drop it. To change it to a percent, you move it 2 places towards the percent and stick it on. A nice trick. Try it. It's all a matter of how you state your problem. Also form this very good habit. Always check that your results seem reasonable by comparing with the following memorized facts. That 1% is 100th, and 10% is, now do you have this memorized? 1/10, and 25% is 1/4, and 50% is 1/2. Most people have that down pretty firm. And 75% is 3/4. And everything under 100% is less than 1. It's a fractional amount. And most basic of all, that the expression 100% is another way of saying 1, or all of something. And 200% is another way of saying 2 whole of something, or if you would, twice something else. If you have these facts, and in fact if you were to go into a business-oriented curriculum, you will have to have not only all of these memorized, but their decimal equivalents and many, many others. In particular, the 8ths, 4ths, and 16ths should be memorized from decimal to percent to fractions. But if you have these few memorized, then you can always look at your results and ask if they seem reasonable by these facts. For instance, a common mistake is for a beginner without thinking to remember he wants to move the decimal point 2 places away, but for some reason starts in front instead of behind and calls this number 3 thousandths. Now, if he could remember our most basic fact that 1% is 100th, so this is 3 times greater, or 300ths. And this certainly is not 300ths, it's 3 thousandths. So again, always look at what you get mechanically, then stop your mechanical reactions and think logically and ask, is that even reasonable? And you would suddenly realize, hey, that's not even reasonable. Then you go back and say, well, what did I do wrong? Well, the decimal point on all whole numbers, in this case a whole number percent, is to the immediate right. Now, 1, 2 places away from the decimal, and I get 300ths. And of course, if we really knew what percent was, we shouldn't have even had to have used that trick, because we know that percent means per 100. So just reading this, instead of saying 3%, we could have said 3 per 100, or if you would, 300ths. So if you're really thinking, you don't have to react mechanically. You can just go from this form to this form automatically, because you know what the two really mean, and you act accordingly. The most common errors occur when a person simply reacts to a visual cue rather than actually thinking about what he or she has and is to do. Let me give you some examples by showing you some extremely common errors with percent representations. For instance, consider the question of what is the fractional value of this percent. You would be surprised at how many people, unfortunately perhaps the majority, would say 1/4. And that's wrong. Do you see why? If you point it out that's wrong, the student would probably say, are you meaning to tell me that 0.25 is not 1/4? Indeed, 0.25 is 1/4. But I don't have 0.25, I have 0.25%. and you must take that into account. And remember, 1% is 100th. And this is less than 1, so it's got to be less than 100th, and this is quite a bit greater than, isn't it? So if you were thinking that I have 0.25%, and to change that to a fraction, well, there are several ways you can go about it. One, let's get away from a percent. So I drop the percent and move this 2 places away, which is the decimal point 0.0025, and not the 0.25 you thought it was. Now this is 25 tenths, hundredths, thousandths, 10,000ths, which reduces to 25 1/400th. And this certainly is not 1/4, isn't it? Now, you could have gone from here in another logical sequence, but still a thinking logic. You could say, well, 0.25 is indeed 1/4, but the percent which I must account for is times 100th, and that gives me the 1/400th directly. But this is a very, very common mistake. Check to see if you've ever made it, and check yourself right off the start. Let me show you another. Can you go from here directly to a decimal without making this very common mistake of saying, well, gee, 1/2 is 0.5, without realizing you don't have 1/2, you have 1/2 of a percent. And 1% is 100th. So this has to be less than 100th. Yet this is a great deal larger than 100th. There's nothing wrong with saying that 1/2 is indeed 0.5. But you must account for the fact that you have 1/2 of a percent. And a percent means times 0.01. This time I wrote it as a decimal rather than a fraction because it's a decimal that I want. Then as you follow through on that multiplication, you will get 0.005, which is certainly a long way from 0.5, isn't it? The trouble with these problems, this kind of problem, is the student is too used to seeing just that by itself, and you react to that. So when you look at a problem, don't just see this. That's not the number. See the whole thing. And if you force yourself always to concentrate on that, then you will not make these careless, reactionary errors, which are very, very common. So the point of this and the past 4 lessons is to realize that a fractional number may be expressed in any one of 3 forms. The most basic, of course, was as a fraction, and then following that we learned how to express it as a decimal, and then finally in percent form. And the purpose of this particular lesson is, if I give you any one of these forms, could you automatically change it to the other 2 forms by whichever of the many methods we have shown you. So if I were to give you a decimal, 0.05, could you change this to a fraction? And of course here you would just think that this reads 5/100ths, so you would write it as 5/100ths and then reduce it. And to change it to a percent, you'd probably think that I want to change to a percent, so I move the decimal point 2 places towards the percent and stick the percent sign on. So we want to go from here both ways, or here both ways, or here both ways. And this particular exercise will give you lots of examples going back and forth, trying to keep your thoughts straight, or to allow yourself the opportunity to find out that they're not straight, and to give you the chance to finally nail down some logic and to think about it, perhaps differently than you have in the past. Following this lesson, the next few lessons will allow you to work with some applications of percents and proportions. You rarely will work with percents without also working with proportions. And that's because a percent is, after all, a ratio. It's telling you how many of something you have per 100. So let's have one last review of proportions to see if we're really ready to begin applications. By now, I hope you're beginning to realize that this is really basic to beginning mathematics and applications of mathematics. So our first generic type of proportion was a fairly simple one, where all you had to think is, I take top times bottom and just show the product without doing it. Set it equal to bottom times top, again showing the product without at the moment doing it. Then I divide both sides of this new equation by the multiplier of the unknown. Then, of course, here it cancels out, and I have solved for that variable. I have solved the proportion. And this side tells me what I have to do. But since I'm multiplying, I have permission to cancel wherever possible. And I can see that a 5 goes into this one 11 times, into here 5 times. And 11 goes into here once, into here 3 times. And 3 times 5 is 15, which is my solution. So again, the most basic approach to proportions is top times bottom, set equal to bottom times top. Then divide both sides by the multiplier of the unknown. Then simplify this arithmetic, and you're done. Then, if it's messy and you have access to a calculator, we simply advise that you see the two diagonals, and the diagonal that has numbers without the variable you will multiply. So in this case, 208.4 times 421.8. Then you divide by the number on the diagonal with the variable, wherever it is. So that's divide by 119.3 equals. Then check where you needed it rounded off. Then round it on your calculator. So this is the number 736 point. There's the tenth. And the digit before it is less than 4, so I round that down by leaving it 8. And you have your solution, in this case, for the variable a. Now, when we get into application problems, one of the techniques we use for solving them most frequently is take the verbal problem and retranslate it into a math statement, which invariably will end up as a proportion at the beginning of this your math career. And if your proportion involves fractions, we do exactly the same thing except with fractions rather than the calculator. And if we're multiplying and dividing by fractions, we first change them to improper fractions, which in this case would be 5/3. In this case would be 32/35. And in this case, 15/17. Then we indicate it as a shortcut as you're solving for t, is you write down what you're going to do before you do it. So I'm going to multiply the numbers on the diagonal which doesn't have the variable. So that's 5/3 times 17/5. Then I'm going to divide by the number on the diagonal with that variable, which is 35/8. But if I divide by a fraction, I multiply by its reciprocal instead. Now we're simply multiplying fractions. So I look for cancellations first, and then multiply what's left. And here again, if you wish, you may bring calculators onto the scene at this point to take 17 times 8, which is 136 over 3 times 35. And of course, that's so easy we should have done that mentally, hadn't we? So you have a reduced fractional answer for the value of t. And of course, very frequently you will write this in mixed number form. And of course, by now we have to presume that you're quite good at all of these processes. And now, hopefully, you are very, very good at the process of solving proportions, either fractional ones with calculators or without calculators. If you are, and if you're reasonably comfortable at starting at any one of these three forms and going to the other two, then you'll find the following lessons will be fairly simple. If you're not, the following lessons can be quite difficult. So let's just work a couple of these to wind down this lesson. For instance, if we had 1.2% and we wish to change it to a decimal and a fraction, it'd probably be easier to go to the pure decimal first. And recall we drop the percent and move it 2 places away from the percent. We've created an additional place, so we have a placeholder 0. And so 1.2% is the same thing as the pure decimal 0.012. Then from here it should be easy to go to the fraction that, after all, reads 12 1,000ths. Then we reduce it, in this case top and bottom, by 4. And we get 3/25ths. So 3/25ths, the decimal 12 thousandths, and the percent 1.2% are three equivalent ways of saying the same amount. And we could start from a pure decimal and ask you to go both ways. Well, to change to a percent, we move the decimal point 2 places to the percent and stick the percent sign on. That was easy. Then to go to a fraction, we pretended like this decimal point wasn't there, changes to an improper fraction, which would be 21/23/7. Then stick on as many zeros here as I have decimal places here, then reduce if possible. And if we have a fraction, we change to a decimal by simply doing this division and getting 0.6. Then once we have a decimal, to change to a percent, we move it 2 places towards a percent and stick on the percent sign. And of course, there are many, many variations of this basic theme, and you should be becoming fairly comfortable with them. This is your host, Bob Fennell. Good luck.